Okay, hello, welcome to those who've joined the webinar. We'll just let people trickle in, so don't worry if you've only caught the second half of this sentence. We'll just give people a little time to wander in as the attendees trickle in. And we'll start in a minute. So if you're not sure where you are, you're in a webinar for the School of Physics and Astronomy. If you think you're meant to be somewhere else, then now is your chance to dive out of the room before we start. We've got a good number of people here, which is good. As I say, we'll start in a second. Okay, I'll let the attendee number stabilize before we. Okay. I think it's stabilized. So welcome everyone. Let me start the presentation sharing and I think we'll be good to go. So there we go. So you should be able to see a presentation on screen as well as our faces, and what you'll find in Zoom is you'll see up at the depending on what device you're using. If you're using a computer, then if you look at the top, there'll be a little view icon. You can select to do it in speaker view or gallery view. Speaker view should be showing me right now because I'm the one speaking. That's the way Zoom works. If you want to see all the faces, then you can put it on various other views there. If you're on a mobile, then you might need to swipe left or right to see that or on a tablet. But you should be able to see various bits. The webinar will begin shortly. It'll begin now. Okay, so a little bit of housekeeping. First of all, this webinar is being recorded for the benefit of those who can't make it to this particular hour. You'll find, given it's a webinar, not a normal Zoom call, I don't know how many webinars you've been to, but your video, microphone, and microphones are off. I've said the chat is off. I suspect you can actually add to the chat. I think that's actually not quite correct. There is also at the bottom of your screen, or under the more, depending on which device you're on, Zoom tends to move things around quite a lot between versions. There's a Q&A option as well. So if you would like to ask a question at any point, then please do that. As a reminder for those who haven't twigged, there's an also Meet the Students session at 1 o'clock today. So there'll be a chance to ask more detailed questions of students and their experiences then as well. Today, we're going to go through an overview of the course here, an overview of physics in Cardiff in general. Okay. So first of all, to meet the team. So this is the team who are involved in student recruitment in here in the School of Physics and Astronomy. There's myself, I'm the Director of Recruitment and Admissions. There's Dr. Sarah Reagan, who's the Director of Undergraduate Studies, and that means that Sarah leads is in charge of all the teaching, and so looks after everything, checks everyone's happy, checks everything's in order, and all the everyone has the information they need, and everyone's doing what they should be doing. We have Dave Brown, Jess Phillips and Paulina Damieka, who are the student support team, essentially. So they are members of staff who work in the student office, making sure that students have someone to go to and ask questions. They're, in many cases, the first port of call for any sort of administrative stuff. So if you don't know where to go on the website or on the student portal and so on, and you haven't got access to something, they're the people that students go to. And then finally, because she's here, Georgina Klemencic is the undergraduate admissions tutor, works with me. Georgina, do you want to say hello?
Yep. Hi, everybody. Yep. Thanks, Chris. I'm George. So I look after admissions, and I'm also a lecturer, and I teach astronomy instrumentation.
Great, thank you. So that's what I said I'd do is as I go. Can I go back on this slide? Will it let me? The other people to meet are the students who are on the call, who you can possibly see on the screen. So I'll come very briefly to who we've got on the call. So just to introduce who they are and what they do. Let's start off with Lucy.
Hi, I'm Lucy. I'm a fourth year student studying an integrated master's in physics with astronomy.
Great, thank you. Rob?
Hi, I'm Rob, and I'm doing my fourth year's integrated master's in just straight physics.
And Quinn?
Hi, I'm Quinn. I'm going into my third year of a 4-year integrated master's physical astronomy.
Helps if I unmute, not mute. A range of degrees and years there, third and fourth year. So the students here, so Lucy, Rob, and Quinn have been through the course to various degrees. So they will be able to answer any questions as well. So if you have questions at any point about anything, please just use the Q&A system. Or if you would rather, you can use the chat. But the Q&A probably is the easiest way to do it. Let us keep track of what's going on. We will then be able to answer them and keep track of them. So a question from someone there. Yeah, you mentioned the webinar is being recorded. We'll be able to find the recorded version. When it's recorded, I will upload the recording has to process, and then I will upload it to YouTube, and the link will be sent round to those who are registered. And some of those who are registered but couldn't make it as well. So you should get an email. It may be early next week by the time that's all happened, but you should get an email to the recording. Okay, but good question, thank you. Okay, so moving on to why we think you're here, or at least why you're logged onto Zoom and listening to us now. What are you going to look for in a physics degree? Why have you come to find out more? Well, and why at Cardiff? You're probably interested in a physics degree, what the location of the facilities are like. So where are you going to be, and what facilities will you have access to? And we'll come on to a little bit of that. You'll be interested in the world-class research that we do here, because as with many degrees, our teaching is research-led, certainly at the higher years, and we'll hear a little bit about a few of those modules later on in this webinar. And then finally, you're obviously going to be taught here. We have award-winning teaching staff who teach you throughout your course, and many of those the world-leading researchers on some of these areas as well. So we're taught by very active and leading researchers in some of these fields through teaching that is evidence-based, and we think does all the things we're trying to do with it. And hopefully the students will we can talk a little bit about that as well. So first of all, onto location. So before we get onto sort of accommodation and so on, there are open day talks on accommodation, but just briefly from our point of view, and to get something from the mouths of people who lived in the accommodation who are here on the call today. But Cardiff itself, I hope it's not a surprise to anyone that Cardiff is the capital of Wales. So it has all the things you want in a capital city. It's got lots of culture, lots of art, lots of sports. Of course, we have the Principality Stadium, it used to be called the Millennium Stadium, right down in the centre of town. We have the picture behind me is the bay. So there's a barrage that isolates the bay from the Bristol Channel. So there's lots of stuff around there. The big dome, this dome thing here is the Wales Millennium Centre. That's got like an opera house in it, and so on. There's various other things down there as well. We're not far from beaches and mountains and so on, so you can get out of the city and get to various beaches down to the south and west, and mountains, the Brecon Beacons and so on up north. And we're a few hours from Snowdonia if you do want to go further afield. That's a little bit far for a day trip perhaps, but for students to go away for a weekend now and again or whatever, that can work. And we're pretty well connected to lots of other places. So we're close. We have the M4 running past, so you can get over to West Wales. You can get back into England for those who come from England, and that connects to the rest of the motorway network. A couple of hours from London by train, for example. So we're not far from other places in the UK that you might want to get to. In terms of cost of living is, roughly speaking, it depends exactly what accommodation you choose and whether this includes bills and so on or not, but somewhere around £300 to £400 per month, which for a capital city is very good indeed. In terms of location within Cardiff, so we are this red dot just right of centre in this map if someone can nod, you can see my cursor, I assume, on the screen. So this, there we go. This red dot here, we're about 5 to 10 minutes from the centre of town. We're about a 10 minutes walk from the Students' Union, the main building, the Centre for Student Life, which is now built there. So this Centre for Student Life, this is an artist's impression. I should have got an up-to-date photo because it is now a finished object. It's now not a vision in someone's head. It is actually an actual building with windows and doors and lecture theatres and so on. So there'll be a lot of student support stuff there as well. But we're very close to the city centre. The main train station is just a little bit off the bottom of this map. You can see on screen. It's about a 20-minute walk from the department, and that's basically across the centre of town. So the centre of town is very compact in that sense. And there's various bits of student accommodation. Some are very close, but some are a bit further away. Speaking of accommodation, all firm and offer holders, firm and insurance offer holders have guaranteed accommodation in halls, in university halls in their first year. So that means that if you put as first or second choice, you'll be guaranteed accommodation in the residences that are run by the university, should you want it. We do have students who live in private accommodation or live at home, for example, in their first year. And other students who come through clearing and so on are generally they're found accommodation, and if there's nothing in the halls, then there is plenty of accommodation in Cardiff that the university will help you secure. So before we come on to where our existing students have lived in terms of university accommodation, then it's the cost is somewhere between £4,000 and £6,000, very roughly. That's accurate to one significant figure. So do check on the website for detailed prices. The closest are St Geneth in Gordon Hall, and Talibon is the biggest one. But to hear more about this accommodation, let's go to students. So Lucy, Rob, and Quinn. I think Quinn, you've lived in 2 of these halls, haven't you? You want to say a little bit about where you've lived?
Yeah. Okay. So I lived in St Geneth Court and Tally. I can't remember where in Tally Court, I think. And due to some issues with the COVID, we got moved out of St Geneth. But yeah, St Geneth is, as it says, closest to the physics building. It's actually a 5-minute walk over some train tracks, which is really helpful for early morning lectures. It means that you don't have to wake up at the crack of dawn in order to get to your lectures, which is nice. Tally is a little bit further away, but there's so many people living in Tally that you can walk in like a group to go to your lectures, so that's not really an issue. They're both very good accommodations. They've got amazing cleaning teams, amazing maintenance teams, and you're probably going to get along with your flatmates because there's no reason why you shouldn't, even if you haven't met them or talked to them before you get to uni, which I hadn't. Everyone's really nice because you're all in like the same situation of just left home.
And you're all thrown together, as you say, everyone's in the same boat. You're all thrown together into some accommodation with essentially random people that you never met before. Lucy, how did you find the sort of making friends in that first year in accommodation stuff?
Yeah, so I'm still friends with like the majority of my flat from first year. So like 3 years later, we're still going strong. But we had like a group chat that was set up beforehand. So we kind of found all each other. So we were kind of chatting a little bit beforehand, which was really good. And I think it's like that for quite a lot of people as well. And just it was so surprising how many like similarities you had with your flatmates as well. So they do really think about kind of who you end up with in a flat, rather than it's not just 5 random people shoved into a flat. It is thought about a little bit. So you will kind of get people from similar situations, or like people you're going to get on with similar hobbies and things.
And you're in, I think you're in one of the Taliban halls, which is a bit of a walk-in. How did you find the walk-in? I say a bit. How far was it? How long did it take?
Yeah, so I was in Tallygate, which is the furthest one from physics. So it was about a 40-minute walk in total, because I had to walk through all of Tally to get to the other end of it. But I met a lot of my coursemate friends from there, just from like walking to each other. And we'd meet each morning, and then we'd walk to lectures together, and you get to know people. You could talk about physics if that's what you really want to do in your morning walk, and just kind of get to like know people. And then you'd have people to walk to like other things with, like, so if you were like going to a physics social or whatever, you'd kind of have people to do things like that with, and you'd make friends really easily.
Yeah, and there, it should be said that it's a 30-40 minute walk from Taliban into Cardiff, which is the biggest accommodation block. There is one that's slightly further, which is University Hall. It's a couple of miles away. There's a free bus that links University Hall to the department, or to the centre of town rather, which is very close to the department. It stops the bus stops very close to the physics department. There are cycle superhighways being built, so I cycle in past Taliban every morning, and there's now sort of a two-way cycle superhighway, so you're not on the main road, you're generally not riding with the buses to get in, which is threading through town, which again gets you very, very close to the department as well. So if you want to cycle, and there's I cycle on my own bike. Has anyone used it used to be called Next Bike, now the OVO Bikes scheme, which is the bike hire university half funds?
I haven't used them to go to lectures or anything, but my friends and I will get them and just go around the park on the weekends and whatever, which is a fun thing to do. So they're really useful, and they're really cheap as well for students. I think they're free for the first 30 minutes, I want to say.
I think that's the deal. If you're a member of the university, staff or student, then they're free for 30 minutes, because they essentially give you get the subscription cost paid for through the university. For anyone for people based in London, they're not dissimilar to the Boris Bikes scheme as their I don't know what the formal name of the Boris Bikes is, but whatever that is in London, with the stations dotted around the city and close to the university. Okay, so that's the university accommodation. Most students in year 2 and above live out of accommodation. Generally not too far from the department. I want to say maybe 15-20 minutes tends to be most student accommodation from the students I've spoken to. There are lots of private accommodation blocks. So these are accommodation blocks a bit like the university ones, big block of accommodation with normally sort of studio flats. So you get a kitchenette and an ensuite flat to go with it. They tend to be a little bit more expensive perhaps than the shared houses, which most students live in a shared house. So, Rob, we haven't heard from you on this. You want to talk about where you're living at the moment, or where you're living this coming year?
So I'm about 15 minutes out from physics, the other way to where you go into town, which is quite nice, because it means actually a lot of that footfall heading towards town, you kind of avoid it, while still being close enough to everything else. And I'm also lucky in that the same people I lived with last year, we're just keeping the same household. So if you do manage to, let's say going into second year, you don't find, or you're not quite so happy with all the people you're living with, you still got at least 1 or 2 more years, you still fine tune that. But if you do really like the people, there's also, the option to just live with them again and save yourself a lot of bother.
So there is a lot of private accommodation. There is, I know the Students' Union has an estate agent, Students' Union estate agent to help find accommodation, which you can or you can't use. It's obviously there are private estate agents around as well. There are lots of them. It's a university city. But Quinn, that has other support for even if you don't use them as well, doesn't it?
Yeah, they have a service where they, for free, will check over your tenancy agreement. So if you can get it a little bit earlier before you have to sign it, they'll check it over and make sure that there's nothing that's a bit iffy, make sure the fact that the landlord is following all of the laws, because there's so many housing laws, you cannot learn them all. So they have specialized teams that will just look over your contract and help you if you want to change it a little bit. They're really helpful even if you don't use them to find your house. They're just helpful because they care that the students at the uni are safe and in good accommodation.
Excellent. All sounds good. All right, we'll move on from accommodation I think, onto research. So we have 6 research groups in the department, and we'll cover the research briefly. I know there's a question in the chat, in the Q&A about PhD research subjects. So most of what we cover today will be focused on undergraduate studies, undergraduate modules. But do listen into these research areas, because there might be things that pique your interest. If you go to the website, cardiff.ac/physics, then that's a place to go. George, can you stick the link to the website in the chat for me while I'm waffling on? So in terms of the research groups, we have physics education research, we have astronomy and astronomy instrumentation, we have the Gravity Exploration Institute, we have a medical or brain imaging group, and then we have the condensed matter and photonics group. And while we let's look at what we've got first of all. So having asked George to type in the chat, I'm now going to come to George and ask her to speak. George, you're in the or you're linked with the condensed matter and photonics group. Do you want to say a little bit about the physics research, just briefly, that goes on in the department?
Yeah, sure. So half of the research associated with condensed to physics. It is an incredibly broad area, and the way I kind of like to think about it is it's really using materials to do a job, or trying to understand the way materials work. So my own research, for example, I'm associated with the diamond research group. So we grow diamonds, and then my own particular area of research is low temperature physics. So I take a material, which in this case is diamond, and I cool it down, and I try and work out how that material works. And most of condensed matter is roughly that.
And it's as you say, you're growing stuff that's experimental. There are theoretical aspects to this. Understanding I guess it's the quantum physics behind why material. That's right. Isn't it?
That's right.
It's worth saying, when you say you're working with diamonds, this is not gems that are going to go on jewelry, right? This is probably worth saying roughly what you use diamonds for, and just in case people get the wrong idea. Sure.
Sadly not. We're not growing gem-like diamonds, although I suppose we could if we wanted to. No, we grow thin film diamonds. So, in my own work, I pattern those thin film diamonds into tiny circuits, and I work out, how the electrical properties change as a function of temperature, for example. And then I use that information to try and create a device that uses the special kind of quantum mechanical properties of those films. But also in condensed matter, we have lots of groups who individually look at different things. So we have a large amount of research into magnetism, for example, or making sort of lasers on chip and things like this. So it is very, very broad.
Yes, it certainly is a very, very broad research topic. Staying broad and going to the brain imaging group. Do you want to give us a very brief overview of, I know it's not your research area, but what happens in brain imaging?
Actually, yeah, fine. So this is a relatively newish research area in the School of Physics. And they are associated with Kubrick, which is, what does that sound? It's Cardiff University Brain Research
Imaging Centre.
Thank you. And so the point of this research being linked with physics is that there's a huge amount of physics that underlies this research area, be it sort of research into how the magnets are created, because in order to take these fantastic images of the brain, you need to use very, very strong magnetic fields. And indeed, an MRI machine, for example, creates a large magnetic field using a superconducting magnet. And also in things like image analysis, there's lots of kind of crossover between image analysis in, say, astronomy that moves into medical research and then into brain imaging. So, you'd be looking at fast updating images of blood flow in the brain, and that could be linked to things like early onset Alzheimer's and dementia research. So trying to detect changes in the brain before people even realise it's happening.
Yes, an incredibly important thing. There are very few areas of physics research where you say this is going to save someone's life, but of course this is something where this kind of medical side of things is exactly that. So if people are interested in that medical side of things, then that's something to do. We do have a medical physics or physics with medical physics degree for those interested. Okay, we've also got the physics education research group on here. So that is a group that looks at making sure our teaching is evidence-based. We try and make sure our teaching is as evidence-based as possible. We're doing all the right things using best practice developed around the world, and helping to drive that best practice as well. And that not only applies to undergraduate teaching and postgraduate teaching, we also use that to look at school level stuff, so going into schools and doing outreach and engagement with schools as well. With myself and a few others are heavily involved in that. Okay, in terms of the astronomy aligned research areas, we have a number. We have 3 groups that are linked to this. So the first one is the astronomy group. So the astronomy group looks at the formation of stars and planets, but also the formation and evolution of galaxies. And it does that in several ways. One is it looks at observations, so taking observations of stars, planets, galaxies, be that looking at the evolution of dust and gas in the Andromeda galaxy, our nearest large neighbor, or looking for stars forming within our own galaxy on large and small scales, or even looking at planets, how planets and other solar systems are forming. We have one of our my colleagues was involved in the detection of phosphine in the atmosphere of Venus. A year or so ago it was announced, which has possible implications for one possible explanation is that's biological in origin, which is quite exciting, although the jury is still out on exactly what causes that. But lots of research there, but on much larger scales, cosmology as well, so looking at the universe on its largest scales, both in time and space, if you like, going back and looking at it at its earliest stages as well, at the cosmic microwave background, that baby picture of the Big Bang. Researchers here do that in an experimental, observational sense. They go and take observations, but they also do it in a theoretical sense. So developing theories and models and simulations, and then comparing that with the observation to see if you can unpick some of the physics that's going on. Because unlike many fields of physics, you can't go and change the parameters of your experiment and make the stars form with a different composition or whatever. You can't do that. You just have you look at what you've got. The only way of unpicking that is to use simulations. The other side of that is the experimental side, which is saying that's all very well. We've taken these observations. What do we, can we make those observations better? And so the astronomy instrumentation group developed instruments. So it's heavily involved in things like the Herschel and Planck space observatories, which are big European missions that went up more than a decade ago now. But they're currently involved in the Ariel mission, which is a mission to go and look at exoplanets, so planets around other stars, and specifically to characterize its atmosphere or their atmospheres. We know the basics of these planets, their size and their mass in many cases, but we don't know much about their atmospheres. And so that's a mission to go and do that. But it's not just all space-based stuff. There is ground-based stuff. We have an instrument called Muscat, which is just going out to Mexico, to the Large Millimeter Telescope, which is a 50-meter diameter radio dish, very high in the mountains of Mexico, where this instrument has gone out there to be fitted to the telescope, and that will look at star formation in our galaxy and in other galaxies as well. In terms of gravity and general relativity, we have the Gravity Exploration Institute. They are linked with the LIGO team. So LIGO is the gravitational wave detector. One of several around the world. There's Virgo and Kagra now as well, and a small one called GEO in Germany. It's a British-German collaboration. But those experiments, those detectors have been detecting gravitational waves from, I think the catalogue is now 50 different objects or mergers of black holes or neutron stars across the universe. And so understanding those, and again, there are the 3 ways of doing this. One is the observations, taking the observations they collected and analysing them. There's the theoretical sense of predicting what Einstein's equations of general relativity say should happen when 2 black holes merge or when 2 neutron stars collide, for example. And what that might imply about the astrophysics of this. Where did these black holes come from? Where did these neutron stars come from in terms of what stars evolve? And then Also the experimental side. So we have an experimental gravitation group that are developing technology for next generation of gravitational wave detectors as well. I can see there's a question in the chat, which I will answer now, but we'll come on to in more detail of what is the difference between astrophysics and the physics degree. It's essentially which modules you can choose. There's a slight variation in modules. The astrophysics degree does astrophysics modules. The physics with astronomy degree can pick some modules from the physics side of things as well. But crucially, they all have the core physics content. And you'll see that in the modules that we talk about in due course. And speaking about modules and teaching, I think that's our next step. So I'm going to hand over to George to take the lead on this section, and we'll hear from George and a few of our from Lucy, Rob, and Quinn about their experiences as well. So George, over to you.
Thank you. So I guess the first thing to talk about when we think about teaching in universities is the facilities on site. So, for example, a large component of the way we teach our modules is in a traditional lecture theatre type setting. And there's an image in the top left of one of our lecture theatres, and this is one of the most comfortable in the building. So one thing to point out in this lecture theatre, I don't know if you've got a cursor there, Chris, that you can wiggle, I'm not sure. Yes, there he is. Right, so at the top there, what you can see is a couple of projectors, and what Chris is hovering over there is a camera. So every single lecture, and this has been the case for a number of years now, is recorded. And not only is the lecturer recorded, but if the lecturer uses the whiteboard or a visualizer, that is also recorded. And it's automatically uploaded onto our sort of electronic site where all of your course materials will be. So even if you miss a lecture for any reason, or you want to simply rewatch it to really kind of cement concepts into your head, everything is available like that. We also have on site a number of laboratories, be that either the teaching laboratories, the astrophysics laboratories, or computing laboratories, all of which are equally important and equally weighted. And also for the later years, we have specific teaching clean rooms for making tiny circuits of the kind I mentioned before, and also a number of research laboratories. And I'll come on to it in a bit, but basically as you progress through your degree, you'll start to have more and more interaction with individual research groups. So it is likely that you will be inside research laboratories. We also have a number of spaces for large group teaching. So what you can see there is, I believe, is this synoptic physics? It is. So, Rob, have you done synoptic physics?
Yeah, I think that might be the picture from the class I was in.
No, okay. Do you want to say a little bit about synoptic physics, perhaps?
Yeah, so you're put into, you get to choose your group of, I think it's 5 people about, and then each week you'll have a different project you need to you solve in about 3 hours. And so typically for this one, we got given a little presentation on how lightning strikes affect aircraft, what measures you take to sort it out. And then, you'll get sent away with a list of questions and you'll have to write up a report on it and do research all in that time as a group. And I thought I really wouldn't like it. Group work never really was that fun. But when you've all got different skills. Some people are better at programming, others are better at the research part. So you all come together, and actually is a really fun, way of learning how to problem solve.
Thanks, Rob. So we do have, that's a really great description of synoptic physics. And you can see that we have these facilities for group teaching. So if it's in a supervised environment, or you wish to get together with a group of people to do group study work, we have bookable spaces for that too. So Chris, do you want to move on to the next slide? Thank you. So I'll say a little bit more about the different teaching methods. So typically you will have between 6 and 8 hours of traditional kind of lecture style teaching, but of course this needs to be backed up with a variety of other techniques to really make sure that all of this kind of new knowledge is taken on board. So each lecture is backed up with exercise classes or online exercises, which can total sort of 3 or 4 hours a week. And on top of that, there is laboratory and computing classes. So if this is, physically being in the lab, or learning how to code. So in the bottom right there, we put we teach Python because it is a transferable skill, really, and it's a very popular language for a variety of different industries. Now, I just want to say at this point that there is nothing to be worried about here. We don't expect any prior knowledge of computing. Lucy, can you say a little bit about your experience with learning Python?
Yeah, so as you say, when I first started, I literally knew nothing. I kind of had a little bit of a computer phobia. I was like, they hate me, they crash on me, this is not going to go well. Within about 3 sessions, I loved it. I still love it. It's one of my favorite parts of the course that has been. It's nothing to be afraid of. If you have any questions, or maybe it's not logically coming out for you, you can ask and people will sit down with you, and or there's a lot of older students to help you in demonstrate the kind of process for you. And if they're really helpful, they'll go through it really slowly if you're struggling. But it's such a useful skill to have. And just you can then, with my project, I used it so much last year, and I literally thought back into first year, and I was like, if I saw myself now from first year, I wouldn't quite believe it. It's amazing how much progress you make.
That's great. Thanks, Lucy. And so Python is led by our colleague Andrea, who is, I must say, a fantastic teacher as well. And I think, everyone seems to enjoy that module. So on top of laboratory and computing classes, we also have weekly tutorial meetings. So that will include, small group exercises in groups of, a handful of people. And also that takes into account your own personal development stuff as well. And your tutor really is there to help you with decision making and making sure as well that you're on track and happy and progressing through your degree well. Now, I will say a bit more about this in the coming slides, but further on in your degree course, you will also take on individual research projects. So I'll say more about that in the next slide. So, Chris, do you want to move on to the next slide, please? Thank you. So when you decide to make an application, you will apply for either physics with astronomy, astrophysics, or physics with medical physics. Now, the real difference between all of these is largely just in the modules that you'll be allowed to pick from. However, I will say at this point that if you make an application for physics and then you subsequently decide that you love medical physics, there is really no problem changing either at enrollment or at the end of the first year, for example, or even later, provided you've taken the prerequisite modules. But the way the degree structure is, structured is you will make more and more choices about which modules you take as you progress through the course. And this is really a deliberate thing, because in year 1, we are trying to make sure that everyone has the same foundational knowledge of physics to enable them to start taking on more and more complex material in years 2 and 3 and 4. But we need to make sure that the core concepts are all there and everyone is on the same page. And year 1 is also what we consider to be a transitional year from school to university, because we also recognise that it is a big change. Moving to university can be a big change. And so year 1 is very much getting everybody up to speed and making sure that everyone has this smooth transition. So I've said the word module an awful lot. So I think in the next slide, we're going to start looking at what those are. Now, we group the material that we take into what we call modules. So this is where we group the topics together into, say, an 11-week course. And for 11 weeks, that's what you would learn. So in the first year, you have relatively little choice. But everyone takes what are called these core modules, which include things like mechanics and matter, electricity and magnetism, There's a mathematical methods module led by our colleague Annabelle, which makes sure that everybody has the baseline of information needed to take forward. In the first year, there is only really one choice you can make, which is to either take an astrophysics module or a medical physics module. So there's relatively little choice, but everything you learn is incredibly important. If we have a look now at year 2, so Quinn, you've just finished year 2, right? Fab, right. So in this year, you can see that the core modules, the list has somewhat shrunk, although all the modules then are extremely foundational and everybody takes them. But you can choose between medical physics and astrophysics. So Quinn, would you like to say a little bit about... Can you still hear me?
Yeah, sorry, you broke up a little bit there. I think you just what you're saying, Quinn, could you say something about, but then...
Oh, sorry. Quinn, would you like to say something about the modules you took during your degree? Because I think you're studying astrophysics, is that correct?
I'm doing a joint degree, but yeah, all of the modules I chose were the astrophysics ones because I like space. So yeah, I chose observational techniques for astronomy, which is nicknamed OBSTEC. Stars and their planets, which is you go into a little bit more detail of how stars and planets are formed, the relationship between them. That's got a lot of gravitational physics in it. And advanced applications of astrophysics, which I took as synoptic astrophysics, which is very much like Rob said, except synoptic is split into physics or astrophysics, because the astrophysics one concentrates a lot more on astrophysics problems. So like we had to calculate the age of the universe, we had to make a satellite and work out how to balance everything that was needed on the rocket to get it into the atmosphere to do whatever research we needed to do. So yeah, and OBSTEC is you actually get to do real research using real telescope data, and that's a double module, so you use OBSTEC in both year 1 and 2. No, semester 1 and 2.
Thanks, Quinn. So OBSTEC, I'm guessing, replaces practical physics. Am I correct in thinking that?
Yeah, that's the second year labs for astrophysics. And I believe that physics has practical physics as their labs.
That's right. So thank you for the intro. That's exactly what I want to talk about. So practical physics. In years 1 and 2, if you are not taking a degree like Quinn is, if you're studying for a straight physics degree, you will have a large component that is practical physics. So you may have already done some practical physics in your A-level coursework. What we are trying to do in teaching you all of these techniques is to be a physicist. So Rob and Lucy will have gone through this as well. I'm guessing, Lucy, did you do OBSTEC instead? You did OBSTEC instead. Okay, so Rob, I'm going to come to you. Can you tell us a little bit about your experience with practical physics?
Yeah, so as like you said, you do it in first and second year. And the main difference between the two is that in that second year, instead of doing one different experiment per week, suddenly you're doing one per fortnight. So you've got a whole lot more time to go back, to do a lot more analysis on it. There's a whole lot more. What do you want to find out about that experiment? And yeah, the themes of the experiments they're made to kind of range over everything. So you've got experiments on optics there, you've got acoustics, you've got electricity. It's a whole load of different things. And each time you've got your own PhD student accompanying you as well to kind of help you out and give you pointers. And they'll then be the ones that mark you as well.
Thanks. So in order to, support you as students in the practical laboratories, you'll be working typically in pairs, and you'll have a lot of support from our PhD students who are what we call them demonstrators, and then there will be an academic in charge of the lab as well. So Again, it can be one of these things that some people think is a bit daunting, but we have a lot of support in place to make sure that everything runs smoothly. Chris, should we have a look at third year now? So Rob and Lucy have just finished this year, and Quinn, you're just about to start this one. So in the third year, there is much more choice. So you only have 3 core modules, and the rest of them is largely kind of up to you. If you are taking medical physics or astrophysics, of course, some of those choices will be kind of compulsory to, tailored to that degree type, but the rest of them you can choose from. And in the third year, you are really moving closer and closer to the sort of cutting edge, sort of state of the art, because each of these modules is going to be taught by a world leading researcher in that area. One thing I want to highlight here as well is, instead of practical physics laboratories, you now do an extended research project. So that's the physics project in the core module. And what that means is, at the beginning of your third year, you will be presented with a menu of options, and there will be a variety of different projects you can choose from, led by a different academic in the school, and you will work very, very closely with that academic to essentially produce knowledge. This is a research project that you will be leading, and you will be in charge of, taking data, analysing data, presenting your research and things like that. So, Lucy, can you say a little bit about your project, please?
So the one I did in third year was on supernovae and whether they produce dust. And I mean, you got to use kind of like real data, like kind of use your kind of programming skills that you've built up through the previous years, like go away, research things. So it was like looking at other papers that have been published, take it back to your own data. Our data didn't come out great, so the results we got weren't brilliant, but I could still talk about them. Was like, maybe this isn't what we expected, we can do some more research into this. And it was kind of like I focused on a specific supernova as well, so G350, and kind of looked in detail at like the images of that and how much dust was around it.
Thanks, Lucy, that's great. And I would say that getting results that are unexpected, that is exactly what you would do as a practicing physics researcher anyway. So that is a really great example. Rob, can you say very briefly about yours, because you're studying for a straight physics degree?
Yeah, so mine, there's a slightly limited range. You can't choose any of the astro ones. But mine was on optical tweezers, which really just consisted of trapping these microscopic particles with a highly focused laser, letting it go and seeing, the forces involved, modeling that movement of this tiny little bead. So it involved a load of, setting up these specific optical layouts.
And that was in the lab?
Yeah, so that was all very much lab-based. There was a bit of computing, but more so, more lab-based than a lot of other modules, a lot of other projects.
That's great. So as you can see, as you're moving through your degree, you are getting closer and closer to, the real research that is happening in the department. And then in the fourth year, please, Chris, you can see that there are no core modules. So the choice is very much up to you. So again, Lucy and Rob, you're moving into this year, so you will have been making your choices now, I'm guessing. This year, this is as close to the real research as you're going to get as an undergraduate, really. And again, all of these modules are going to be taught by world-leading researchers in their respective areas. I can say perhaps a little bit about my own module, which is instrumentation for astronomy. So this is it's kind of a traditional type of module. I split the assessment 50% exam, 50% coursework. So in the module, I teach you about the kind of more cutting edge detection mechanisms that detection schemes that we use. And then there is a research component to the module where you work together in groups to research a new or upcoming, or you choose an instrument, you choose a telescope, and you do some research on that telescope and the findings that telescope or instrument has made, and then you report back. So it's using a variety of teaching methods there, but and most of these modules will do something very similar. But the key thing here in this year is your physics project will take up the majority of the time, because it is like the third year project, but bigger. So again, Lucy and Rob, you'll have made your choices already, have you?
Yeah.
Lovely. Lucy, what are you doing?
So I am doing instrumentation for astronomy.
Oh, hooray!
I'm also doing energy and gas in interstellar space, advanced data analysis, and also general relativity and gravitational waves, and gravitational wave astrophysics.
Fantastic. Well, that's a great selection. And Rob, I'm guessing as well, you've chosen your project, you've chosen your modules.
Yes, I'm also doing the advanced data analysis, large molecules in life, physics and reality. So a bit less kind of heavy, a bit odd, bit of weird ones. And then gravitational waves and general relativity.
That's fantastic. That's great. So, and then again, that will be done alongside your physics project, where again, the goal is very much knowledge generation. So, unless anyone, Chris, perhaps if you want to add anything, we can move on to the next slide.
No, I think we've gone through all the modules. You talked about project work, so you'll probably skip this slide because we've talked about that already. And go on to other elements of teaching. Thank you, George, for that run through the course. So as I put in the chat, some of those modules are brand new. So we've got a little video introducing some of those brand new modules on our channel. I'll put a link to the YouTube channel up shortly. So the way we support you, just in the last sort of 5 minutes when you're here. So I want to cover the way we support you, but then also the applications process. I know there's a question just come in about that as well. So supporting you, we have a student mentor scheme. So that's where students coming to the first year for the first semester are matched up with a mentor, and they meet on several times or a number of times over the course of that of the first semester to cover all manner of things, quite frankly. Lucy, you were a mentor last year, is that right?
Yeah, so I was a mentor last year, and I just had like a group of first years, and I just answered like any questions they had, so any questions that you might feel are like a little bit silly, or maybe stupid questions. There aren't any stupid questions, but maybe things that you don't want to take to your personal tutor. Like I answered all those kind of things. And then we also kind of did sessions like on housing when it got a little bit later in the term, and like how to find a house, how to choose like your housemates, budgeting, so how to make a budget to because it can be quite a different environment being at university, and then also more the physics side of things, so like going over lab diaries and how to kind of write that a bit better and things, because for some people it can be really like a new daunting aspect of the course.
And then Quinn, as a mentee, how did you find the mentor scheme help?
I found it really helpful. You've got one mentor and a group of about 10 mentees, and it's nice because it's kind of, when you're in lectures, you don't have to talk to anybody else, but these groups you have to, so it's like built-in friendships, which was nice. It meant the fact that you found people that you wouldn't usually talk to on your lectures to talk to and help each other with work, and the mentors themselves are really helpful. They're happy to teach you things that you might not have learned before you got to uni, give advice with things in accommodation, and just how to tackle that change from living at home to living at uni and trying to do a course where it's up to you pretty much to run your life. And it was all very, very helpful. And I'm still friends with my mentor.
Excellent. So it's lots of tips that can be much easier to get from other students than it can be from staff, and lots of help and advice there as well. Okay, so in terms of applying to Cardiff, we've covered a little bit of this elsewhere, but because we have essentially a common degree to a common first year, sorry, to all of our degrees, apart from one option in the second semester. Changing the flavour of physics, if you like, is relatively easy. So whatever you apply for, you can change it later. That means you can change it when you enroll. You can say, actually, I know I applied for physics. I'd like to do astrophysics or whatever. Or at the end of your first year, you can do that as well. That means that when it comes to applying, my advice would be not to use multiple options for physics degrees for Cardiff, because you can change your mind when you're here. So just pick one option for Cardiff, the one you think you're probably going to want to do. And then, as I say, you can change your mind later if you want, and that would be my advice, at least. In deciding the 3-year or the 4-year, so the BSc, which is the 3-year option, or the 4-year option, then which is the MPhys, then you make that decision. Well, you do have to choose when you're applying, and that might affect the offer you get. So you'll get a slightly higher offer for those coming in for the MPhys. But you can then change your mind at the end of your second year. So you make the decision at the end of your second year, sometimes even a bit later, as to which degree scheme you're going to follow. You have to be getting sufficient marks in your first and second year to be able to do it. That doesn't normally limit most people. About a third of our students go on to do the 4th year, the MPhys. Some decide that it's not for them. They want to go out into the real world and do it. Some decide they want to do the MPhys to get some extra physics and some of that research project experience. The other thing we haven't really talked about much is the professional placement. So there's a professional placement you do at the end of your second year if you elect for that. And again, you make that decision by the start of your second year. There is a compulsory module for those students called Pathways to Success in Physics, I think is the name of the module. And that helps not just those students, but any student can do that module in learning about applying for placements, applying for jobs, using the skills you've learned in physics in a better way. And I'll put a link. We've got a playlist of some students that did that module and did some professional placements in this last year to find out more about that. In terms of the actual mechanics of applying, so in the last couple of minutes, so someone has asked, what do you look at in a personal statement? So yes, when you apply, you put in your GCSE grades, you put in your predicted grades, or your teachers put in your predicted grades, and you put in what A levels you're studying. So that is kind of all covered. What we want in a personal statement is more about you, more about what drives you in physics, why you're interested in physics. Most students who are applying for a physics degree are interested. They're doing it because they're interested in physics. It's not normally a degree people sort of do by accident. So you will have some interest in some particular area of physics, maybe, or you might just love knowing about what makes the world go round, or what makes the universe work. That's fine as well. You don't have to have a specific focus. You might have a career you're interested in going into. Obviously, this is non-binding. Don't worry if you change your mind over the coming years. The application requirements are on screen. So ranging from AAA to ABB, including maths and physics. Now and again, we do hear about people who are studying they aren't able to study a physics degree for various reasons in their school or college. If that is you, then we'll discuss options for coming in with the maths. There's obviously a lot of ground to make up in the start of the degree, but we can support that. We do ask typically for maths and physics A level. With the third A level can be another subject, or it could be Welsh baccalaureate if you're doing if you're based in a Welsh school. And again, the international baccalaureate scores are there. There's a lot more links on Course Finder. I'll put a link up in a second to that when I've finished speaking. I talked a little bit about mentoring and finance and getting a bit of support, but the fees are £9,000 and there are financial awareness talks. There are scholarships. So if you're a firm applicant, so we're your first choice, and you get 3 A's at A level or above, 3 A's or above at A level, then you can get this scholarship or international other qualifications. You have to be a UK student for this. Other qualifications apply as well. So IB, whatever, if you're based in the UK. Then that's a £3,000 over the course of your degree. And there are scholarships within physics for the top performing students in the years, which you can look at as well. Prospects for physics degrees are excellent. So the vast majority of our students, the vast majority, go on to successful careers using the skills they've built up during a physics degree, even if the career they go into is not directly physics related as well. So I think I've answered that question. Just picking up the last couple of questions coming in. So someone has asked, do we require specific grades in specific subjects? We require maths, physics, and one other. As I said, if you're not doing a physics A level for some reason, because your college wouldn't allow it or whatever, you didn't fit in with the timetabling or something, then do get in touch. But maths, physics, and then a third subject. Total UCAS points, we don't normally consider it at a first stage, but if, for example, you were borderline with the grades you end up with when you come in, as with many universities, we do sometimes accept students with just below their offer if you've missed a grade or so. Can't guarantee that because it depends on the way the rest of the field work. Obviously, this year there were more A's and A stars than in previous years, so that did sway things slightly. Doing a fourth subject, for example, again, can help if you are borderline. If you've got a fourth A level, and that can help as well. I would say the priority should be making sure you get those 3 top grades. So if you think doing a fourth subject is going to harm your chances of getting the A's and B's at your top 3, then think carefully about whether doing a fourth subject is the right thing to do. Okay, I hope that helps. Get in touch with us if you've got more questions on that. And there's another question here about access to HE diplomas. Do we consider them? So the person who asked this question has said, currently studying an access to engineering and an A-level in maths. That's actually the perfect combination, doing an A-level in maths plus the access. Yes, we'll definitely accept that. If you want specific requirements, now I'm doing this from memory, which is always dangerous. I don't have the spreadsheet in front of me. It's 45 credits at level 3 with 30 distinction. Is what we require, and we obviously want it to be a physics-related, physics or science-related access course. Okay, other projects, essay-based or hands-on is another question that's come in. It depends on the project you pick. Rob, yours was a bit more. I mean, you do produce an essay. You produce a report at the end of it. So there's not an exam, or there is halfway through. There's a viva and a presentation. Sometimes a chat with your supervisor and other member of staff about your project, just to check you've got full understanding. But it's very some of them are very hands-on. Some of them are computational. So I think Rob and Lucy, you did sort of opposite extremes of that, I'm guessing. So Rob, yours was hands-on, and Lucy, yours was computational. Is that right, Rob? Do you want to go first?
Yeah, so mine was probably one extreme. There was still, and you still have to do computing. You need a way to analyze this data, but especially compared to one I saw on modeling pendulums, which is completely coding based, no experimental work whatsoever. So yeah, mine was the other end of that. And Lucy,
mine was more like research based, which at the time I was a bit like, oh gosh, a lot of reading, but it wasn't. It was more just like researching kind of, and then using the coding behind it. So it wasn't as much reading and like writing as I thought it was going to be. So even though it was that kind of more research based kind of side of things, rather than actually like in a lab doing things, it was still really enjoyable.
Excellent, thank you. So I hope that answers the question. Now there is a chance later on at 1 p.m. to come and chat to some of our students, so including the 3 who are here now and some other students as well. So I'm going to put the link to that, the registration link in there. You can probably hear me typing. To meet our students, visit. So that will be a registration link for another Zoom call at 1 p.m. So in 55 minutes. And that will give you a chance to ask questions of the students that you might not feel comfortable answering here. We're just past 12 o'clock, so we should stop, giving us the later opportunity as well. As I said at the start, we will get the recording uploaded to YouTube and send you the link to that, so you can go and watch that. That may be in the next, may take a couple of days to get that through the system, given it's the weekend. If you have any more questions, then drop us an email at physics-admissions at cardiff.adc.uk, which I just put a typo in, so I should fix that. There's the email address in the chat as well. And let us know if you've got any more questions there. So if I put that slide on the screen, you can see the details there. Go to cardiff.ac.uk/physics or the contact us for more information. Thank you very much to George, to Lucy, to Rob, and to Quinn for taking part in this. And we hope to see some of you. I'll see those three, Lucy, Rob, and Quinn at 1 o'clock. And there's some of you who've been here. We hope to see you at 1 p.m. to ask students questions as well. Okay, thank you very much, and goodbye.